Hello and welcome to another session in mathematics. In this session we'll be looking at matrices, and our focus today will be on inverse of matrices. But before that, let us take a review of our previous lesson. Welcome back. Today we'll be focusing on inverse of matrices and how do we solve the inverse of matrices. Let us start. Inverse of matrices. Now when we have a matrix, let's say A, we'll have a matrix A. The inverse of matrix A is written as A raised to power minus 1, and A raised to power minus 1, which is the inverse of A, is given as adjoint of A all over determinant of A, therefore written as ADJ A all over determinant of A. Okay, that's the formula we use in solving inverse of what? A matrix. So that is to say, if you're asked to find the inverse of a matrix, you need to first of all find what we call what? The minor. I taught that in our previous class. Then number 2, you find the minor of A. Also, number 2, you have to find the cofactor, which has to do with changing of signs, cofactor of A. And then 3, you have to find the adjoint, which is the transpose of the cofactor, adjoint of A. And then lastly, which is number 4, you have to find the determinant of the original matrix. Determinant of the original matrix. And then the determinant of the original matrix is there, what we call what? The determinant of A. Okay, then you now find the inverse by dividing the adjoint by what? The determinant. So let us quickly take an example. We have A to be equal to 2, 3, 4 and minus 1, and we are asked to find the inverse of A. The inverse of A. Let us start. I told us that the first thing we need to do is to find what? The minor. The minor. Okay, so minor of 2 is equal to what? Cancelling this and this, we have minus 1. Minor of 3 is equal to what? 4. Minor of 4 is equal to 3, and then minor of minus 1 is equal to 2. I'll be rushing this because I know we are conversant with this. So the minor of the set A would then be equal to minus 1, 4, 3 and 2. Is that correct? So that's the minor of this. And then after we must have find the minor, we'll find what? The cofactor. The cofactor, and the cofactor is what? The change of sign. And we have the cofactor of A to be equal to minus 1. This will become minus 4, and this is minus 3, and then this is 2. Is that correct? Fine. Then we find after we must have found the cofactor, then we'll find what? The adjoint of what? A. And the adjoint of A, I told us, is what? The transpose of the cofactor, and that will give us minus 1 minus 4, and then minus 3 2. Is that correct? So we then find step 4, we find the what? Determinant of what? A. Determinant of A. And determinant of A is equal to what? Anybody? Determinant of A is 2, 3, 4 minus 1, which is equal to 2 times minus 1 minus 4 times 3. 2 times minus 1 is minus what? 2. Minus 4 times 3 is 12. We have minus what? 14. Minus 14 as our what? Our determinant of A. So now the inverse of A is given to be inverse of A, written as A raised to the power minus 1, is equal to what? Adjoint of A all over determinant of what? A. And our adjoint of A is given to be what? This. We have minus 1, minus 3, minus 4, and then we have 2. Okay? Then divided by what? Our determinant of A, which is what? Minus 14. So this is over 14 minus 14, and this is simply minus 1 over minus 14 minus 4 over minus 14 minus 3 over minus 14 2 over minus 14. That is just what we have here. And then a minus a raised to the power minus 1 is equal to, this will cancel this to give us 1 over 14, and this will cancel this to give us 2 can go into this to give us what? 2 here can give us 7, and minus will cancel minus, so we have 2 over 7. Then this will cancel this, we have 3 over 14, 2 here 1, 2 here 7, we have minus 1 over 7, and that's our final answer. Okay, so let's take an example on 3 by 3 matrix. Okay, question number 1. If Q is equal to the matrix on the board 1 0 2 3 minus 1 7 4 5 minus 2, find the inverse of Q. Okay, solution. This will take us a very long process. So first of all, we'll find what? The minor of this. You remember how we find the minor? Do you still remember how we find the minor of a given problem? So let us start. We have the minor of 1 to be equal to, cancel this, we have minus 1 7, we have 5 minus 2, and that will give us minus 1 times minus 2 is 2, 7 times 5 is 35 minus 35, and that will give us what? Minus 33. Okay, then for 0, we have 0 to be equal to, cancel everything here, we have 3 4 7 minus 2, 3 times minus 2 is minus 6, 4 times 7 is what? 28, so we have minus what? 28. Added to this, we have minus 30, minus 34, right? Yeah, minus 34. Then for 2, we have 2 to be equal to, what is left here? 3 minus 1, 4 and what? 5. And that will give us 3 times 5 is 15 minus 4 times minus 1 will give us minus 4 minus 4. And that will give us what? 19. Because this plus this is plus. Okay, then we'll come over to 3. 3 is equal to, eliminate everything here, we have 0 2 5 minus 2, and this will give us 0 times minus 2 will give us what? 0 minus 5 times 2 is 10, so we'll have minus 10. Okay, then we'll go over to minus 1. Minus 1 is equal to, we have 1 2 4 and minus 2. 1 times minus 2 is minus 2, 4 times 2 is 8 minus 8, and that will give us minus 10. Then for 7, we have 7 to be equal to, eliminate everything there, we have 1 0 4 and 5. 1 times 5 is 5 minus 0, that will give us what? 5. Okay, let's go over to the next page. We'll go over to 4. 4 will then be equal to this and this. I have 0 2 minus 1 7, 0 2 minus 1 7. Okay, and then that will give us 0 times 7 is 0, minus 2 times minus 1 is what? Minus 2, and that will give us 2. Okay, then let's go over to 5. We have 5 to be equal to, this will go and this will go, 1 3 2 7, 1 3 2, 7. So we have 1 times 7 is 7, minus 3 times 2 is 6, and that will give us what? 1. Okay, so we have the last number here, which is minus 2. Minus 2. And minus 2 will give us eliminate this and eliminate this. I have 1, 0, 3 minus 1. 1, 0, 3 minus 1. 1 times minus 1 is minus 1. 3 times 0 is 0, minus 1. So we then form the matrix minus 33, minus 34, 19. We have minus 10, minus 10. We have 5. We have 2, 1, and minus 1. Okay, so the next step, we are asked to find what? The cofactor of Q. The cofactor of Q. And the cofactor means what? Imputing the signs. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus. And then the cofactor will then be equal to, this is minus 33. This will give us plus 34. This is 19. And then this will give us 10, because minus minus will give us plus, minus 10. And this is minus 5. This is 2. This is minus 1. And this is minus 1. And that's our what? A cofactor. Then step 3 is to find what? The adjoint. The adjoint of Q. The adjoint of Q. And the adjoint is the transpose of this, where this becomes the first column, this becomes the second column, this becomes the third column. So we have minus 3, 34, 19, minus 33, 34, and 19. We have 10, minus 10, and minus 5, 10, minus 10, and minus 5. We have 2, minus 1, and minus 1. We have 2, minus 1, and minus 1. Okay, so we found the adjoint. Then the next thing is to find the determinant of Q, determinant of the original matrix. This is the original matrix, you remember? So we have 1, 0, 2, 3 minus 1, 7, 4, 5 minus 2. I just brought out the numbers over here. Okay, so applying our method of finding the determinant, what do? We have determinant of Q to be equal to 1 into, eliminate this and this. You have minus 1 times minus 2, which will give us what? 2. Then minus 7 times 5, which is 35. Is that correct? Then minus, because this is plus, this is minus, this is plus, remember. Then minus 0 into, this will cancel this, 3 times 2, and then minus 7 times 4. So 3 times minus 2 will give us minus what? 6. Is that correct? And 7 times 4 will give us minus what? 28. Then plus this plus here, and next number is 2 into, you eliminate this and this. We have 3 times 5, which is 15, minus 1 times 4, minus 4. Okay, then we have this to be 1 into 35, 2 minus 35 will give us minus 33. We have minus 0 into minus 6 minus 28 will give us what? Minus 34. Right? Plus 2 into 15 plus 4 will give us what? 19. Then if we multiply through, we have minus 33 minus 0 plus 2 times 19 will give us what? 38. So we'll add up. Minus 33 plus 38 will give us what? 5. So our determinant of Q is what? Is 5. Then we are given that inverse of Q is equal to adjoint of Q all over determinant of what? Of Q. And that will give us this is the adjoint of Q, so we'll write it down. Minus 33, 10, 2, 34 minus 10 and minus 1, 34 minus 10 and minus 1. We have 19 minus 5 and minus 1, 19 minus 5 and minus 1. Then all over our determinant, which is what? 5. So we have all over 5. And this is simply minus 33 over 5, 10 over 5, 2 over 5, 34 over 5. Remember there is a bracket. Minus 10 over 5, minus 1 over 5, 19 over 5, minus 5 over 5, minus 1 over 5. Okay? And then we then have minus 33 divided by 5 will still remain minus 33 over 5. So we have minus 33 over 5. 10 divided by 5 is what? Is 2. Right? 2 over 5 is still 2 over 5 because it cannot be divided. 34 divided by 5 will still remain 34 divided by 5. Minus 10 divided by 5 will give us minus 2. We have minus 1 over 5. 19 over 5. We have minus 5 divided by 5, which will give us 1. And then we have minus 1 over 5. And that's our Q raised to power minus 1, which is the inverse of what? Q. So that's our answer. Okay, so we'll stop here today. Thank you for being part of today's class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with inverse of matrices. I will stop here. So do wait to use the lesson note on the platform for better information on what we've just done. And feel free to leave your questions or comment on the comment section. Till we meet again in our next class, stay safe and bye.